Alrighty, welcome back, ninth graders. Today we are talking about solving polynomials. Okay, so this is a competency in order for you to progress on to the next math level. So make sure you're paying attention. Get a notebook, piece of paper, and turn your thinking caps on. Let's get going. So before we start, you might be wondering, why is Albert Einstein in the background? He doesn't have anything directly to do with polynomials, but he was an avid mathematician and physicist. So, thought we would have it thematically connected this time. All right, so polynomials. So poly refers to it's has Latin and Greek roots, and it refers to many. So poly, many. Nomial has a etymology or the history of the word referring to a name, right? And so nomial, when it comes to math, has to do with terms, right? So this is a expression or an equation or a function that has many terms. Okay, that's what a polynomial is. Okay, the requirements in order to be a polynomial, if you want to be a polynomial, you've got to have exponents in the expression that are positive. They have to be integers, so they cannot be fractions like we saw in the exponents and radicals video last week. And an example of a polynomial would be 7x squared plus 12x minus 27. And so it might look like there's just one power here, right? The 7x squared, one term of the power, but actually there are three. There are three. So the 12x, x is raised to just the first power, right? And 27, you could argue, is being multiplied by x to the 0th power. Because what is x to the 0th power? It is just 1, right? It's just 1, okay? So that is the definition of a polynomial. That's where the name came from, and those are the requirements. All right, so now what we're going to do is we're going to look at these examples, these expressions, and try to determine which of the following are polynomials. So go ahead and pause the video and try this one out. All right, I hope you had a chance to pause the video and give these a try. Now let's jump into it. So the first one, x squared plus 2x plus 3, is going to be a polynomial because there's more than one term, right? You've got x squared, you've got 2x, and you've got 3, right? 3 different terms. Okay, now for our second one is going to be considered a monomial. Okay, and now we're still going to be largely classifying x to the 5th expressions as being polynomials because normally they come with additional terms, right? Most of the time when you have a expression involving x to the 5th power, it's also going to have added to it x to the 4th term and x to the 3rd term. And so generally with a expression with a 5th degree is going to accompany different terms. So this is a monomial, but it's going to be largely considered in this polynomial family. Now, the number 2 is just a monomial. So normally we're not going to consider the number 2 to be a polynomial. Even though there is a slight bit of ambiguity between x to the 5th and 2 because they're both monomials. But to make it a little bit more clear, whenever you see something to a power, we're generally going to consider that in the polynomial family. But even though sometimes you're going to have the highest degree term by itself, that is a monomial, but we're still considering it in that family. All right, so for our final one, 4, we got x plus 3x to the 0th power. So really this is involving 2 terms, right? Your x and then x to the 0th power, that would just be 1. So it's really x plus 3. That is also a polynomial. You've got more than one term. All right, now we're going to jump into defining polynomials. Okay, so there are different types of polynomials, and there are 2 main ways we describe them. So we either describe a polynomial by the number of terms, and we describe polynomials by their degree. So we initially already looked at what a monomial would be. So that's only one term. So for example, 6 or 4x cubed, or even something as big as negative 5a squared times b cubed. So even though it has 2 different variables, it is still only one term because it is one group of variables being multiplied by each other. So it's one massive quantity. Okay, so then binomials, this is going to be 2 terms. So here we've got 6x plus 2, could be ab to the 4th minus 5, y plus 2f. It doesn't matter if you're adding degrees of different value or different variables, that would still make it 2 terms. Okay, so even though you've got a degree of only 1 with y and f, you still have 2 terms. It's still a binomial. Next, we've got trinomials, 3 terms. So we've got 3x squared minus 5x plus 8, a cubed plus 4y minus 7. And then even this one, which has a leading coefficient, which is 1/2, right? So 1/2w minus 2s plus t. Okay, so polynomials is anything with more than one term. All right, now we're going to look at defining polynomials for degrees. So a constant polynomial would just have a degree of 0. So as you might remember from learning about exponents, x to the 0th power is just 1. So the degree here would be 0. Any constant term, any constant polynomial would have a degree of 0. So that would be the same thing with negative 2/3. Okay? And then a linear polynomial is going to have a degree of 1. So that would be x plus 8. That would be 3/4 x minus 6. And then a quadratic polynomial, quadratic comes from the root quadrus, which actually has to do with a square. So anything x squared, right, is going to give you x to the 2nd power. So quadratic, remember, degree 2. So that would be 3x squared minus 2x plus 7, 5y squared minus 1/4. So even though this top one is a trinomial and the bottom one is a binomial, they're both quadratics because their highest degree is 2. Okay. Finally, the cubic polynomial has a degree of 3. You would have 5x cubed, or you could have 2y cubed minus y plus 4. So again, trinomial with a cubic trinomial on the bottom, and you have a cubic monomial on the top. So now we're going to get into simplifying polynomials. So now that we know what they are, we want to try to use our skills of simplification to put them into a more easily understandable form. So first one we have is x cubed plus 2x cubed plus 4x squared plus x plus 0. Okay, so for this one, you might initially think that you can combine x cubed and x squared, right? But imagine x represents meters. We couldn't combine meters squared and meters cubed, right? One represents area, the other represents volume, right? Those are not two of the same thing. Just like if you had meters per second, that would be speed. But then if you have meters per second squared, then you're dealing with acceleration. Those are two different quantities. Okay, so we're only able to combine terms with the same degree. So x cubed plus 2x cubed, that's going to be 3x cubed. 4x squared has no other like terms, so we're going to keep that. And then finally, we're going to add the x, and we can just get rid of the 0. We don't have to include that in our expression. It's taking up space. All right, so our next one, xy cubed plus y cubed plus x cubed plus 4. So how would we simplify this one? What do we think? We couldn't simplify it. We can't simplify it because xy is not the same as y. It's not the same as x. It's its own term. It's its own type of term. So we can't combine y cubed with xy cubed. We can't combine x cubed with y cubed. And so it's a trick question. It cannot be simplified. Alrighty, so now we're going to look at the distributive property and how that is going to help us solve our polynomials. So we briefly mentioned the distributive property in past videos, but the distributive property says that whenever we have a quantity immediately outside of the parentheses of an expression, we can multiply everything in that parentheses by that quantity. It's the same thing, right? So as we have down here below, we can either have 3 groups of 2 plus 4, right? And we can add those up before, right? We can add those up before we multiply by 3, or we can separate it out. We can do 3 times groups of 2, which we have here, and add that to our 3 times groups of 4. Okay, so that is the distributive property. All right, and so now we're going to get into solving polynomials and factoring, what it really means to solve a polynomial. So first up, solving, when we're dealing with polynomials, is about finding the zeros of a polynomial. And so a zero of a polynomial is when the output, or the right side of the equation, is equal to 0. So in order to do that, we use factoring, which is taking a quantity and turning it into its products. So that would be using the distributive property in reverse, right? So for example, if I had the number 5, I can factor the number 5 into 5 times 1. I have the number 10, I can factor it into 10 times 1, and I can factor it into 5 times 2. All right, so when we want to find the value of our input x for a given output y, we can use this strategy for any output value. That's why we solve in using finding a 0. For example, if I'm looking for the input at which the output for our polynomial function is equal to 10, I will start by subtracting 10 from both sides. So I'm focusing on one conglomeration of terms on the right-hand side of the equation. And our strategy for finding our zeros is factoring, because let's take an example. If I have x squared plus 2x, and I factor that, it becomes x times x plus 2. So now I have a simpler expression, And I can easily find the zeros because I know if I do this and I say, all right, 0 times whatever is in the expression here, 0 times whatever that is, has to equal 0. And so when I turn it into these smaller binomial chunks, I know exactly what x value is going to give me a 0 in that situation. All right. So now we're going to look at quadratics as our kind of first foray into polynomials. So the general form of a quadratic is this: ax squared plus bx plus c is equal to 0. Okay, now this is a lot of variables and exponents and letters here, and so it might seem a little confusing, but let's break it down. So a is always going to represent the leading coefficient. It follows the English alphabet, and it's going to be the leading coefficient or the coefficient of the highest degree. So whenever you have a polynomial, the highest degree term is going to go first, and then you're going to go down the ladder. So highest degree term first, then you move to the right, that's going to be the second highest degree term, then the third, then the fourth, all the way until you get to c, which represents this constant term, or x to the 0th power. All right, and so we can, if we wanted to factor this quadratic, we could write it in the form x plus some constant term, p, or x plus some quantity p times x plus some quantity q, right? And that would then, when they're multiplied, we could do x times x, that would give us some value of x squared, then p times x, that would be px, and then we would have x times q, that would be qx. We combine like terms. So what we're going to end up getting is we're going to have our p and q, when multiplied together, are going to give us our constant term c, and then p times x plus x times q is going to give us our middle term, right, or the value for b here. So as an example, we have x squared plus 9x plus 14 is equal to 0. And so for this one, we have to find what two values, when multiplied by each other, will give us 14, and when added together will give us 9. So take a moment and try that. All right, I hope you had the opportunity to give that one a try. And so we can go ahead and just factor 14. So we know 1 times 14 equals 14. We know 7 times 2 gives us 14. And so let's try them both. So if I add 14 and 1, am I going to get 9? No. But if I add 7 and 2, that gives me 9. So then I can rewrite this example as x plus 7, close parentheses, times x plus 2, and that will be my factored form. And now we know when x is equal to negative 2, one side of the expression is going to be 0, and when x is equal to negative 7, the other side of the expression is going to be equal to 0. All right, so now we're going to take a look at quadratics and the signs of the factors. Okay, so if we have a quadratic equation that's in the form ax squared plus bx plus c is equal to 0, that means that our factors have to have positive signs for both of them. So p and q both have to be positive, right? So if we're multiplying two quantities and they are supposed to give us a positive c, there's no way one could be negative and one could be positive, right? They both have to be positive. And if our middle term is positive, there's no way that we can have a negative and a negative, right? Because a negative plus a negative is just going to be positive. So that means both of our factors, p and q, both have to be positive. Now, for our next example, we have ax squared. So ax squared is positive, but our middle term is negative and our final term is positive. And so for this one, we know a negative times a negative is going to be a positive. So then our positive c, that would make sense. And a negative plus a negative is going to give us a negative quantity. So again, both p and q would be negative here. Now for our next example, ax squared plus bx minus c. So in this example, one of our quantities has to be negative and one has to be positive, because when multiplied by each other, that's the only way we're going to get a negative output. And so now for our middle term, if our middle term is going to remain positive, that means what? That means that our bigger value has got to be the positive value. So when we're adding a positive and a negative, if our negative was bigger, our b value would be negative. Okay, so that's going to mean that the positive sign is going to be for a larger factor, and our negative sign is for a smaller factor. All right, finally, ax squared minus bx minus c. This example is going to mean that just the opposite of the last one, because our middle term is negative, we are going to have our larger factor be negative and our smaller factor be positive. All right, let's finish with some practice. So factoring practice with quadratics, we've got our first one, x squared minus 2x minus 15 is equal to 0. And our second one, x squared plus 2x minus 15 is equal to 0. So go ahead and try to factor these expressions and find the value at which these expressions are equal to 0. All right? Okay, I hope you had a chance to do that without checking for the answers first. So here we go. We've got our first thing that we can look at is we can say, okay, what two values or what are the factors of 15? And because it's negative, we know we're going to have one positive and one negative. So we know we have 1 and 15. We've got 5 and 3. And so if we do 5 times 3, we will get 15. If we do negative 3 times 5, we'll get 15. Negative 5 times 3, we get 15. And so we know it's going to be one of the two. And we know because our middle term is negative, that means the negative has to be the bigger value. So it's going to be negative 5 and a positive 3, right? Which will give us when we do 3x plus negative 5x, that'll give us the negative 2x that we want. So our final answer is going to be x is equal to negative 3 or x is equal to 5. All right, for our final one, we know the factors here again are going to be 5 and 3, but this time our middle term is positive. So we're just going to be switching our positive and negative signs. And so we have we're going to have a positive 5 here, and we're going to have a negative 3. So exactly the same as we did the last one, except we're just switching where the signs go. All right, that's it for today. Remember that this is a competency for you to move on to the next level. You're going to have a quiz in the Google Classroom. I hope you found this helpful. And don't forget to check out the other videos in the math stream if you are interested in looking forward to what they're doing in 10th grade, or you want some revision with some concepts in the prior grades. All right. Thank you for tuning in, and we'll see you next time.